So today we're going to learn about something called rational exponents. I'm just going to wait till everyone's ready here. Okay, so when we hear the word rational, we want to think fraction. So rational, fraction. Rational exponents can be expressed in two different ways. They can be expressed in root form, or they can be expressed as a fraction in the exponent. So if I have some root, so it doesn't necessarily have to be a square root, it could be a cubed root or a fourth root, fifth root, and so on. If I have some kind of root, and if there's any exponent on my x, I can actually switch this into a rational exponent or a fraction exponent by writing x to the exponent b over a. So the number outside the root becomes the denominator of the rational exponent. Okay, so there's a couple things that we have learned throughout our mathematical studies that we just kind of understand, right? So if I just had an x, there's a couple things that we just know about this x. What do we know about the exponent on the x if we don't see it? Charlie? It's always 1. Okay, what do we know about the coefficient or number in front of the x if we don't see it? It's 1. So a regular root, just like this, we know that this x kind of has like an exponent 1 on it, like we just talked about. And a regular root is a square root. Agreed? So for square roots, we don't see a number in front of the root. For any other kind of root, like a cubed root or a fourth root or whatever number root, we will see the number in front. But we have to imagine that for a square root, there's kind of like an imaginary 2 in front, because it's a square root. So we can also express a square root as an exponent to 1/2. Okay, so that's just kind of something that's understood. If you see a regular root, it's a square root. For any other root, you'll see the little number in front of the root. And then, of course, if we don't see an exponent on a variable, we understand that that exponent is a 1. Okay, so let's see if we can change these guys into rational exponents here. So imagine that there's kind of like an exponent 1 on your x. If I go to express this as a rational exponent, it will be to the exponent 1/3. Someone want to do 2 for us? Charlie? Perfect. Okay, and 3? Who wants to do that one? Lauren? Yes. So remember, when we don't see anything in front, we imagine that there's kind of like a imaginary 2 because it's a square root. Sheila?
Could you reduce that, or is that?
Yes, yes, good point, actually. 4 divided by 2, we can actually just simplify to 2.
So when there's nothing there, we just simplify to 2.
Right. So this is actually going to be particularly helpful to those of you guys that have graphing calculators, because I don't think you have, like, on some graphing calculators, maybe like the older ones, you don't have the particular button that you need to evaluate some of these specific roots other than square roots. So you can actually use rational exponents on a graphing calculator. GD, shh, whisper if you're talking about this, okay? Yeah, we can actually use like this kind of method on our actual graphing calculators, or like either any calculator really we can use this with. So we're going to change these guys into their radical form, so the root form, and then we're going to evaluate. So if I see 16 to the exponent 1/2, I can actually enter this on my calculator, so maybe we'll try entering this in 2 ways on our calculator. So on your calculator, I want you guys to do 16. And then you're going to press your exponent button. For some of you, it might look like a little hat. Others of you, you might have like a y to the x button or something like that. And in order to enter in a 1/2 as an exponent, we usually want to open up a set of brackets and write like 1 divided by 2 or 1 over 2. Different calculators will have different ways of doing this, but we should get out 4 if we've done it correctly. Again, make sure that there's brackets around this 1 over 2. Okay, so see if you can get 4 out of that. Did you get it?
Yeah.
No? So just, again, just make sure that there's brackets here after you press your exponent button.
What? Guys,
Okay, the other way that we can calculate this, did you get it now? Pardon? You got it? Okay. The other way that we can calculate this is by putting it into its root form. So if I see an exponent of a half, we're kind of doing this but in reverse, right? So an exponent of a half is actually just a regular square root. We have the square root of 16. So we imagine kind of like there's a 2 here and an exponent 1 here, but we don't have to write it. And of course we know what the square root of 16 is. What's the square root of 16? 4. So we can calculate it this way, or we can also put it into our calculator as square root of 16. Okay, so when we do 27, if we want to put this into root form, the cube root of 27 is what we're going to get. So the denominator becomes your root out here, and then this usually will remain on the value, but of course we don't really write exponent 1, so we just know that that remains there. Okay, so in your calculator, a lot of you guys have a regular root button. Some of you guys have a couple different things. So some of you guys have a button that looks like this. Okay, if you have this calculator with the blue and orange, and it has like some like fraction buttons and stuff like that, that's probably what you have. Others of you are going to have a button that looks like this. And it's probably somewhere around your regular square root button. So find your regular square root button. You might have to press shift to get to it. And here's how we're going to enter this into our calculator. Find that button. If it's the one that I mentioned before, you can literally just press that button and enter in what you want to enter in. If it's the one that has like the little x root outside or y root or whatever, you're going to enter in 3 because I want to do a cube root. And then you're going to press that button. So you might have to press shift to get to it. And then you're going to enter in what you want to cube root. Got it? What'd you get, Thomas? 3. We should get 3, so test that out on your calculator. If you press the regular square root button, this is not going to work. You need to find the x root button or whatever that looks like on your calculator. Matt?
Can you just do the same process you did up there?
Yeah, so the other way that we can calculate this is you can do 27 and then press your exponent button and do 1 divided by 3. Okay? If you're having any trouble finding this x root button, I can help you with it after, okay?
Is one of them like better to do?
No, not necessarily.
Is that all in choice?
Yeah. Okay, so let's take a look at this one. So when we switch this into a root, does someone want to help us with how we would express this as a root? Charlie? Yep. To the 4. Perfect. So if you want, you could calculate to the exponent 4 and then fifth root it. See if you can get that entered into your calculator. Really what we want to do is we're taking the fifth root of 16. Okay, or you can try entering this into your calculator. Okay, you should kind of know how to switch back and forth between these, but however you want to calculate it on your calculator is fine. A lot of times it's just going to be variables though, so you won't actually be calculating. So really the skill that I'm interested in is just switching between the forms. Okay, what do we get here? It's probably going to be a decimal.
1.74.
1.74? Everybody else get that? Okay. Any questions so far? Okay, so when we're dealing with variables, so like x's, y's, stuff like that, we're just going to change from root form into rational form, and then kind of like see if we can simplify anything, basically. So we'll start off just with switching into rational exponents. So because this root goes across both of these, I want to apply that denominator of 4 to both the x and the y here. So when we switch it, it's going to be x 3 over 4 and y 2 over 4. And like Sheila suggested in the previous example, wherever we can reduce fractions, we always do that, right? So I don't usually ever write a fraction of 2 over 4. What would I write 2 over 4 as?
1/2.
Yeah, 1 over 2. So just reduce, and then now we've got the exponents in rational form. Okay, same thing with the next one. So we're imagining that there's a 2 out here. It's a square root. We're going to do a to the negative 3 over 2. And this one already has a fraction, so it's like 4 over 3 over 2. So we're going to have to simplify that. So I just want to show you off to the side here. If I'm just looking at a regular number, if I have 2, what do I know about the denominator of any regular number? What is it? 2 over 1. That's right. So when I'm dividing 4 over 3 over 2 over here, I want to think of this as like 2 over 1. When I have a fraction divided by another fraction, we reviewed yesterday that we will take the second one and flip and multiply. Okay, and then we can just reduce 4 over 6 to 2 over 3. Matt?
If you were doing this on a test, like, would you have to like show your work with that, or could you just use a calculator to get it?
I don't really need to see like your fraction work, but if you don't show it and you get it wrong, then I can't give you any part marks for the stuff you don't show, right? So. Okay, it's always good to be able to, like, I get that your calculator knows how to do it, but it's always good to, like, just for your own number sense and getting to, like, work with fractions, like, it's good to try to do these things and to know, like, why your calculator is giving you out what it's giving you. Okay, and then finally, we have something with a negative exponent, so we know we can switch that into a positive exponent. Okay, guys at the back, are you going to talk the entire time, or, like, can we just have, like, a few minutes where you're focused in here? Gotta stop, okay? Talking about math things every so often is fine, but the entire lesson is not. It's very distracting. Okay, so we have something with a negative exponent here. We're going to apply that negative exponent rule that we talked about yesterday, and I'm actually just going to bring it down into the denominator and make it positive. So applying the negative exponent rule, we talked about how we can move it to the opposite side of the fraction. So we'll move it down. And that's done. Any questions on that one? Josh?
So I just do move it down. Like, I'm confused where, like, how you made the a exponents is divided by 2 underneath the, like, y by.
So anytime I have a negative exponent, we can make it positive by switching the side of the fraction that it's on. So if it's in the numerator, which a is right now, we move it into the denominator, or vice versa. Like if I have y over, let's say, x to the negative 6, I could move this up and make it positive. So I would have y times x to the positive 6. So that's the negative exponent, really. You just switch the side of the fraction that it's on. Okay? Okay. Let's try a few more examples here. So this whole thing up here has a negative exponent. So I'm actually going to take the entire thing that has the negative exponent, so this is actually what Josh was just asking about, and we're going to bring it down into the denominator, and then we can make it positive. So I'm left with just 1 on top, and now we have 2z cubed to the positive 2 times w to the 5 times z squared. We don't really need this times symbol. We know like if there's brackets there, obviously it's being multiplied, so we don't necessarily have to write that. Okay, I'm going to apply this exponent here, and also remember that the whole thing is being squared, so I also have to square 2. So 2 squared is 4. And what do we do when we have an exponent on an exponent? What did we talk about yesterday? Yep, so z to the 6, right? Okay, and then we talked yesterday about how we know that these questions are fully simplified when all like variables have been gathered. So I'm noticing here that we have a z to the 6 and a z squared on bottom that just need to be gathered together. So how many total z's do we have on bottom?
8.
We have 8, yeah. And usually what we do, guys, is we will write them in alphabetical order. So
Do we actually have to like do that?
it's not like make it or break it, but most of the time you're going to see variables written in like alphabetical order. So
Why is the 4 not brought like the
it's all just being multiplied, right? So is 4 times 1 times 7 the same thing as 1 times 4 times 7?
Exactly.
Right. So I can just leave, whenever we're dealing with like variables and coefficients, we usually just leave the coefficient in front of all the variables. So coefficients always in front and then variables after. Okay, any other questions on that one? Okay, let's try a few more. Okay, so the very first thing that you're going to do whenever you see roots in these types of questions is you need to change the roots into rational exponents. So that's going to always kind of be your first order of business, change roots into rational exponents or fraction exponents. Okay, and then you can start gathering common variables and using your exponent rules and so on. So in this part right here, we're just going to make each of these have a rational exponent where the denominator is 3. So x 2 over 3 and y cubed. Now notice that this part is outside of the root, so that one is going to remain y squared. Okay, so only the things that the root extends over are included in the root. We can clearly see it ends right there. Okay, now I want to gather all the x's together and I want to gather all the y's together. So in the x exponents here, what am I going to do if I have an x divided by an x? What do we do with their exponents?
Subtract.
We have to subtract them. And what do we need when we're subtracting fractions?
Same denominator.
Common denominator, perfect. So I need to write the x on the bottom. Think of it as x to the exponent 3 over 1. I need to write that with a denominator of 3. So multiply the bottom by 3 and the top by 3, we'll get 9 over 3. Okay, so I'm just finding a common denominator by multiplying in 3 on top and bottom there. Okay, and then with the y's as well, we also need that common denominator. So the y also happens to have a denominator of 3. So think of this as 2 over 1. And again, I want to create a common denominator here. So I'm going to multiply the bottom and top by 3 here. So we're going to get 6 over 3. The denominator with the x's just has to be the same, and the denominator with the y's has to be the same. If they happen to be different common denominators, that's totally fine. So just make sure that the denominator with the x's is the same, and if the y is different than that, then just make sure that those two are the same, or however many. Matt?
Instead of like doing it that way, because it's just 2, right?
Mm-hmm.
Just add 2 to the 3 to make it 6, and then like 1, so it would be 7 over 3.
That's what we're going to do.
Yeah, but like just adding it instead of doing it that way.
You kind of need a common denominator to add it, though.
Yeah, but
So I'm not sure exactly what you're...
like, because you're doing the extra step of like, writing that, and then like it's all going to be put together in the next step.
Yeah.
But you could just make it 7 over 3.
I think I actually want to see you doing this step. I want to know that you know how to do it. Okay? Okay, the x's, just as you guys said, are going to have the exponents subtracted because they're being divided. What's going to happen with the y exponents? We add them because they're being multiplied up here. So we have x to the negative 7 over 3 and y to the positive 7 over 3. And then we're just going to apply that negative exponent rule one more time and move the x with the exponent down and make it positive. So don't flip the fraction or anything like that. We're just literally taking this term, moving it to the bottom, and then you can change the negative to the positive. Can I write this as y over x? So here's a question. It should follow, like if you guys agree with that, it should follow that if I have y over x, that's equal to y squared over x squared. Is this true? Test an x and a y value. If y is 3 and x is 2, is 3 over 2 equal to 3 squared over 2 squared? This is not equal, right? So can I cancel these? No. You weren't going to do it? That's good. Okay, any other questions about this before we move forward? Okay, last one. Do you guys want to try this one yourselves and then we'll take it up? Okay, try it out. I'll give you guys a couple minutes. Okay guys, I'm going to throw a couple steps up here to start. Okay, so this should be your first step here. Change your rational exponents into fractions. Exponent on an exponent that is multiplied, so that should give you -6 there. And think of this as a 1, exponent of 1. So there's an imaginary 2 outside of each of these roots. Okay, so I did a couple things here in the next step. Just applying the negative exponent rule, so I'm bringing the m to the -6 down to the bottom and making it positive. And then same thing with q, but I'm bringing it to the top, making that exponent positive. And 4 divided by 2 is just 2, so we're just simplifying that fraction there. Okay, one thing that we have left to do is all like variables need to be gathered. So all of these m's, we need to gather those up. So I'll do this in 2 steps here. So think of this as an exponent 1. We're multiplying on the bottom here, so it will be m to the 7 on the bottom. Okay, and let's just think about this one. We could apply quotient rule here. We could do 2 minus 7, and then we'll have to apply the negative exponent rule again. If I have 2 m's on top and 7 on the bottom, and I cancel out 2 from each, how many are left? 5 where? 5 on the bottom. So I'm going to be left with 5 m's on the bottom here. Okay, and then I'm just going to switch these back to their root form. So any rational exponents, we'll switch back to roots. Just be mindful, we don't want it to look like this is a 5th root here, so maybe what we would even do is just write m to the 5 times root p, just so that it doesn't look like m and then 5th root of p. So just make sure that you're clear here. Any questions on this one that I can clarify? Charlie? Which one? This? So how did we get this? So that was already there in the original question, right? So I'm just carrying that down. Okay.